All right, so I'm going to give you a little bit of a video. I won't always give you a video. I need you guys to work and try to figure out how to do the problems, but I'm going to give you a little video here to help you try to find the concentrations of the sodium carbonate, the sodium bicarbonate, and the sodium chloride in your titration sample, just in case you have been struggling like crazy and you can't find it. Okay, so first of all, let's talk about the titration curve of sodium carbonate. All right, sodium carbonate is a diprotic base in this case, because when you put sodium carbonate into solution, the sodium ion dissociates, and then you have the carbonate ion, and the carbonate ion is the conjugate base of a weak acid. Therefore, it pulls protons off of water. It has a strong affinity for protons and pulls them off of water and makes the solution basic. And that's why we're titrating with an acid. Okay, so the bicarbonate ion pulls 2 protons off of water, different water molecules. So the result is, one off of whatever water molecule it can find. So the result is a concentration of the hydroxide ion. And as you add acid, you consume the concentration of the hydroxide ion. As soon as all of the hydroxide ion, or all of the carbonate ions have protons on them, or as soon as all the hydroxide is used up, then the titration will finish, right? So let's look at a titration curve here. All right, so if I have my titration curve, I'm plotting pH versus the concentration of hydroxide ion that I'm adding. Or sorry, the concentration of hydrogen ion that I'm adding, right? Because I'm adding acid. And the pH of the sodium bicarbonate or sodium carbonate solution, as we discussed, is going to start off as basic. All right, so in this pH curve here, if we're looking at, we started with when we add the sodium bicarbonate, or sodium carbonate and the sodium bicarbonate for that matter, the pH is going to start up high. All right, the pH of the solution is going to be high. Then as we start to add acid, the pH will try to go down, but initially the sodium carbonate and sodium bicarbonate are going to be used up. First, it's the sodium carbonate, because it's the CO3 2- ion, right? And that one, this is the carbonate ion. The bicarbonate ion has 1 proton with it, and so it has a weaker affinity for the proton. So this is the first thing that's going to be used up. And the pH will not change. It'll go down a little bit, but not change drastically until the concentration of hydrogen ion equals, so that all the carbonates have all been converted to one of these. So we have H plus combining with the carbonate to form the bicarbonate. As soon as all of these have a proton, the excess H plus ions will begin to accumulate, and that'll change the pH, and so you get a drop. As soon as the concentration of hydrogen ion gets high enough that the bicarbonate ion will take one, then you get the bicarbonate ion beginning to take the hydrogen ions. And so then this will convert, the added protons will begin to continue to protonate these and make the H2CO3. As the proton concentration is enough to convert the bicarbonate ion to H2CO3, now H2CO3 decomposes into water and carbon dioxide, right? So you'll see some bubbles when you get to the H2CO3. So this is the consumption of the carbonate ion converting to the bicarbonate ion. This one is converting the bicarbonate ion to the H2CO3. Now, if I start off with just carbonate ion, sodium carbonate, then the amount of carbonate ion, this length here, will be the same as the length of this curve there, right? So this length would be the same. If, on the other hand, I started with some carbonate ion and some bicarbonate ion, and this is our case, right? Then the length here will be related to this, and the length here will be related to the amount of bicarbonate ion that was converted from carbonate to bicarbonate, right? So there'll be a certain length here that's related to this stuff, But then whatever was just a bicarbonate in the first place, that amount will be there. And then the concentration of H plus ion here that you consume will be 1 to 1 molar for this, 1 to 1 molar for this, and for that as well, right? So that is how you're going to be able to identify the carbonate and the bicarbonate ion from the your titration curves. And the rest of the mass that is not titrated, so you'll be able to identify how many moles and thus grams of these components that you started with, and the rest that was not sodium carbonate or sodium bicarbonate must have been just the NaCl. Oops. Okay.